Hi guys, welcome to today's show. So far we've been looking at financial maths, specifically growth and decay. And then we've been looking at various concepts under that. And all these concepts are just a build-up of what it means maybe to save money or to invest money, or what it means to also even consider when we talk about interest and loans and all of those things. But now today we're actually going to look at compound decay and timelines. Compound decay will then be the opposite of compound interest. It's just the same thing but with now a minus sign. But let's just quickly do a recap of everything that we've kind of looked at so far and then get into today's lesson. Now, firstly, remember our big idea has been finance, and under finance we've looked at growth, which was simple interest and compound interest. And then we've looked at simple interest and what it is all about, which is an interest that is constant in your investment. And we've looked at straight line depreciation or decay, where the goods and services that you actually might be having at that time, they going down at the very same rate. And then we've also looked at compound interest, but which is an exponential growth. And this means that each and every month you are not getting the same amount of money in terms of interest. You're getting interest on interest. You'll hear that when people are talking about compound interest, they normally use terms interest on interest. That's why compound interest is actually the way to go. Now, the very first question I want you to think about, which we've been looking at this question, is how exactly do people save or grow their money? And then also to you now, what has been your best choice of saving your money? Let's say you're trying to get those shoes that you know for a fact that at home they're not gonna get you or anything of that sort. And then they say, no, we can give you an extra money just to see whether you can save. What did you do to try and save up for that particular thing that you want? Now, for compound growth, remember that our keywords had to do with term and length of time, and we said we deliberately used term and length instead of number of years, because in compound growth, you don't always get interest on a yearly basis. You can even get it on a monthly basis. We also looked at our principal amount, which was the initial investment amount that you start with. We also looked at the accumulated amount, which is actually the amount that you get after a certain period of time. Also, remember at one lesson we looked at inflation. Inflation had to do with the rate at which goods and services grow at, right? So they increase by. You remember that I think a few years ago bread cost this much, now bread costs a lot of money, and then later on as well bread will be costing more. It is all because of inflation. We also looked at the concept of interest rate. Interest rate was when we're talking about nominal and effective interest rate. Then lastly, we looked at also the compounding period, which means how often do you get your interest. Remember, just a quick reminder of our formula for compound growth was A is equals to P open bracket 1 plus I to the exponent of n, where the labels are my A is the accumulated, P would then be the principal amount, and then I would be the interest, n would be the number of times interest is earned. Remember that I said we can always look at A as also what we call future value, and we can look at the principal amount as the present value as well. So just remember that, because at a later stage, that's what we're going to be using as the financial mathematics terms. Also, there was a conversion between nominal and effective interest rate. So the formula to do that was 1 plus I effective, is equals to 1 plus I nominal divided by m to the exponent of m. Where the labels are, you know that I effective The effective already tells you that that's effective annual rate, and then the norm means nominal annual rate, and then my M will then be the number of compounding periods per year. Now, compounding periods per year, I said at the end it says per year. What this specifically means is we don't look at nominal and effective interest rate over a longer period of time. No, we only look at it on a yearly basis to say, what did they promise you for the whole year? That's the nominal interest rate. But what did you actually get because of the compounding? That's the effective interest rate. I will repeat that again. What did they promise you for the whole year as the interest? And what did you actually get because of the compounding period? What they promised you is the nominal, and what you actually get will then be the effective because of the compounding period. So please remember those two. This formula, you will need to memorize it and know how to use it, because it's not going to be part of your information sheet. They normally do not include it there. So you need to really know this formula, because there will be questions where you need to convert between the two. Also, you need to remember that certain assets normally actually lose value over time. A car that I bought at 20,000 today, tomorrow definitely it will not be worth 20,000. It will be worth way less than that. Also, these assets are normally like vehicles and equipment. So your cars, your buses, your taxis, your tractors, those are all the vehicles that we are talking about here. And then the equipment can be a TV, it can be a computer, or a playing console for that matter. The loss of value is normally called the depreciation or decay, which means one and the same thing. And then depreciation is always something that occurs yearly. Now, guys, just on a general basis, remember that when we look at cars, we normally look at the year model. The year model normally does what? It influences the price. So now if I look at a car maybe from 2001 and I want to buy it at this present moment, definitely it will not be the same as it was when it was in 2001 when I was buying the car. It will be way less than that. Why? Because it is a very long period after that. So that's why you need to look at this. But if I look at something that I bought 2 months ago, it might still be closer to the very same value that I bought it for when I sell it 2 months later. So you need to look at all of those things. That's why depreciation happens on an annual basis and not necessarily on a monthly basis, because after 1 month you haven't really used that thing that much, so you can always negotiate your way around it, though you know that it will still be at a percentage that is less than whatever that you bought it for. Now, our main concept now is decay, right? So we've looked at the straight line decay. Now we're moving on to the reducing balance one. And the keyword has always been scrap value or book value, which means one and the same thing, but at times they normally use in the value trade in value. So at times they also call this the trade in value. The formula that we normally use to calculate depreciation on a reducing balance method is the same as the formula for compound growth, but with a minus now. So this here is actually supposed to be I in a small letter, although it's a capital letter there. So that's actually supposed to be a small letter. And then our A is the scrap value or the book value, or what it is worth after a certain period of time. And then the principal amount will then be the rate of depreciation, which is our I. And then lastly, it will be the number of periods. So how long has this particular asset been with you that you are trying to sell? But let's try and put all of this into perspective with a question. Now, you buy a new console, right? Let's say a PlayStation 5 or an Xbox Series for 12,500. What will this console be worth in 3 years' time if its value decreases at a rate of 15% per annum according to the reducing balance. Now, if you look at this, there is nowhere where I'm going to be saying to you per annum compounded. Per annum compounded. I will never say that. Why? Because depreciation is a yearly thing. It has nothing to do with months or anything like that. It normally is calculated on a yearly basis. So you see compounded something on depreciation, there's something wrong there. Now, on a reducing balance method, remember that we are looking at compound growth, but with a minus. Now, we just need to write down all the values that we know. We know that the principal amount is actually 12,500. Our interest, let me just go back, it's 15%. So this is 15% per annum. And then our N, is actually 3 years, right? So this is 3 years. And we are looking for the A value. Now, to calculate this, I will first start with the formula, 1 minus I to the exponent of N. And then I'm looking for A. I know what my P is. That's 2,5, which is the same as like 2.5. Into 1 minus, not plus. See, one of the common mistakes that we normally make is as soon as you see compound something, you already think compound interest. And this is going to be 0,15 to the exponent of 3. Then, guys, you really do not need to try and crack your brain here. You have a calculator for a reason. So you just go to your calculator, substitute everything as is, 1 minus 0.15 to the exponent of the 3. And you find what the answer is. Now you can see, if I was to find a value that is greater than the 2,500, then I would really have a heart attack, because there is no way that I'm using depreciation and I must get a value greater than 2.5. So that's one of the ways you need to look at when you're trying to do your maths, so that you know whether you are on the right track or not. So this is 1535. 1535. So that's what it will be worth after 3 years of having this console. So you can see that although we love these gadgets of ours, depending on the rate of depreciation, if I buy it today, definitely tomorrow when I sell it, it will be way less than that. But then it is all in the fun of using it when you are just getting it at that time. Guys, that's all from me for now. Let's take a quick ad break and I'll be back with some more. Stay tuned.